Okay, lastly, we have a bit of a tricky one. So what happens if we have an indice or an index that's a fraction? So let's say I had 2 to the power of a half. So what we usually do is the number that's the numerator, the denominator, that would be the root. So, if we do a square root, okay, so that 2 is that 2, and then 2 to the power of that 1 becomes that 1. Okay, we'll do a couple examples. It's a bit of a tricky thing. It's basically saying the square root of 2. So if it's a half, it's going to be the square root of 2. Let's do 4 to the power of a half. That would be the square root of 4 raised to the power of 1. I don't write the 2 there because I don't have to, because it's the square root, and I also don't really have to write the 1 there. So if I want to just write what I have to write, in this case, the 4 to the power of half is just the square root of 4. Pretty simple. Let's do another number. Let's say 8 to the power of a half. In this case, it's going to be the square root of 8 raised, this 2 goes there, and raised everything to the power of 1. So I don't really, again, have to write that. But let's say there's a really different number. Let's say it was 8 to the power of 2/3. That's a bit weird. So the numerator is going to be the numerator is going to be the power in the end. So the denominator is going to be the so much as, if I can say it like that, the root. So it's going to be the cube root of 8, and this would be raised to the power of 2. Okay, there is a simpler way to look at this. I'll quickly, let's use this example to show you there's 2 ways of solving this kind of equation. Well, not an equation, just the indices. So I'm just going to write it here, 8 to the power of 2/3. Okay, so I'm going to write it on both sides. Okay, so the kind of the long method would be exactly like I showed you now. So I would take the cube root of 8 and I would square that. So this 2 is that 2 and this 3 is this 3. And the cube root of 8 is just like what times what gives me 8, so that would be 2. And then it would just be squared, and in this case it's 4. But another way of looking at it, and usually this way you'd have to use your calculator less. Usually in these kind of problems you see normal numbers repeating in this section, like 8, 27, 64, etc. So if I see an 8, I immediately think 8 is 2 to the power of 3. So that 8 and this 2 to the power of 3 is the same thing. And then I raise this to the power of 2/3. But if I have this situation, it just means that I have to multiply that. So if I look at 3, and that 3 is 3 over 1, times 2 over 3, then I know the 3's would cancel out, and I would be left with 2 over 1, which is 2. So this would just be 2 to the power of 2. Let's do a different example. Let's say we did 27. I know that was, it's not the easiest things to do. Okay, so again, I have 2 ways of looking at this and solving this. The one is I can go the square root kind of trick, doing the cube root of 27, and that squared, and the cube of 27 would be 3, and that squared, so 3 squared would be 9. Other option would be saying, 27 can be written as 3 to the power of 3. And that is all raised to the power of 2/3. And I know if I say 2/3 times 3 is going to be 2. So this is 3 to the power of 2, and that's 9. So either way you can do. Sometimes, I know this looks weird because there's the fraction and you might think I'm overcomplicating the things, but if you were to write an exam where calculators are not allowed and sometimes they give you weird numbers, then this route is sometimes easier because you kind of make these indexes or indices smaller. But I mean, if you're allowed to use a calculator, then this route would work. But yeah, either way. So in this case, I wouldn't have to know that, like if there was a really big number, like, oh, what is the power, what's it squared, or what's the cube root of it. But well, again, like I said, at the end of the series, we'll do a couple of examples. Okay, so to finish off, let's just look at that rule. If I used variables, let's say it was a to the power of b, or like x to the power of a over b, then it would be the bth root, if there's something like that, everything to the power of a. Okay, so these indice rules is something that you're going to have to remember, but just take heart. The more of them you do, the easier it becomes. So later it becomes second nature. So now it might be tricky. For me, a trick is if I ever forget, I just know that anything to the power of a half is the square root of that number. And anything to the power of a third, let's say 27 to the power of the third, that would be the cube root of that number. So if I ever forget which of these go where, I know a half would be square root, so I know that 2 would be there, and that would be over there. Cool. See you in the next video.